Alright, boys and girls, this is Miss Twisdale. Sorry, I was eating a piece of candy. Here's lesson 4.3, equivalent ratios and multiplication tables. So today we're going to be working on finding equivalent ratios using a multiplication table. So that sounds complicated, but equivalent ratios means equal ratios. You guys have used multiplication tables before. Alright, so we're going to start with our first example problem. Okay, sorry, this thing's in my way, I can't see. So the table shows two rows from the multiplication table, the row for 1 and the row for 6. So if you look at the row for 1 and the row for 6 have been highlighted here. Okay, and the ratios shown in each column of the table are equivalent to the original ratios. Ratios that name the same comparison are equivalent ratios. So if we have an equivalent ratio, it's just like an equivalent fraction. It's just another way to say it. So our original ratio, looks like we're doing bags to apples, was a 1 to 6 ratio. So what we did is we highlighted all of the 1s and all of the 6s, and then we can fill in our table by simply looking up and down this chart. So 1 and 6, 2, down to 12. That's how we got 2/12 here. 3 and 18. So we got those two here. 4 and 24. And 5 down to 30. So you can use that multiplication table to find these different equivalent ratios. So you could also use just a pattern to, like we multiplied this number each time by 6 on the bottom and by 1 on, or by the new number on top. So you could do that. So it's just another way, guys. It's another way to help you solve the problems of ratios and creating those tables and patterns. So let's see it in a real example problem. So Jessa made fruit punch by mixing 2 pints of orange juice with 5 pints of pineapple juice. So picture that. She's got a big bowl, she's got some orange juice, she's got 2 containers, and then 5 containers of pineapple juice. They're pints, which is not very big. To make more punch, she needs to mix more orange juice and pineapple juice in the same ratio. Write 3 equivalent ratios for 2/5. So she has to make sure that for every 2 pints of orange juice, she has 5 pints of pineapple juice. And if she wants to double or triple that batch, then she would need to make sure she does the correct ratio so it tastes good still. So we would use the multiplication table, and we would find the first number, 2, we would highlight across. And then we would find the second number in the ratio, 5, and highlight across. And now, where these line up is each of those ratios. So we have 2/5, 4 and 10 would be our next one. So she could use 4 orange juices to 10 pineapple juices. Keep going. 6 to 15. Oh, looks like they filled in the 15 for us, so we just need to fill in the 6. And then 8 to 20. So that's how we could use a multiplication table to find those ratios. And so if she wanted to make a huge batch of juice, she would need 8 orange juices and 20 pineapple juices in order for it to taste the same. If she got too much orange juice, then it would taste too orangey. If she got too much pineapple juice, it would taste too pineapple-y. So she needs to make sure that it's just the perfect mix. Okay, so here's an example problem. So you're going to do the exact same thing. Well, I'll do it first, then you can do it on the try it. As I did on the last one. So I'm going to take my top number, which is 3. And I'm going to highlight the row. Oops. Sorry, wrong button. Let's just do green. Okay. And then I'm going to take my bottom number, which is 7, and highlight that row. And where the numbers line up are the equivalent ratios. So 3 and 7, well, it's already listed. 6 and 14. 9 and 21. And some of you are starting to notice there's other patterns that you could also follow, and that's fine. It depends on which pattern works best for you. We could keep going. 12 and 28, 15 and 35, 18 and 42. We could keep on going and going and going. So notice that it just depends. We multiplied both numbers by the numbers up here in order to find the numbers in our equivalent ratios. So I'm going to erase my multiplication chart, and you can go ahead and try that example problem. Okay, so in the example problem, it's a little bit different because the larger number was on top, which is fine. We just need to make sure we list it on top each time. So we had 5 and 2. So because I want to remember that 5 is on top, I'm going to start and go from the bottom to the top. Okay, so 10 and 4 would be my next one. 10 to 4 would be an equivalent ratio. I could also do 15 to 6. And I could continue going on and on. Each of these would be fine. 20 to 8, 25 to 10, 30 to 12, so on and so forth. Just make sure that you start with a larger number over here. So these all need to be larger, okay, than the ones on the bottom. Hopefully you did well on that one. Let's go ahead and move on to the next thing. Excuse me. All right, so here's two try-its. Instead of listing it as a table, it just listed it as a fraction. But you can still use the same strategy to solve to find two equivalent ratios. Go ahead and try it on your own. Okay, so to find two equivalent ratios of 2, 6, I can use the multiplication table by highlighting across 2, highlighting across 6, and then I can just go straight down 4 and 12. I'm going to do different ones. It doesn't matter which ones you use. All of these are equivalent. So you can use any of those two sets of numbers. Okay, so let's say I'm going to use 8 and 24. Oops, that was weird. Let's try it again. 8 and 24. Or I could use 6 and 18. All of these are equivalent ratios. 18 and 54. Just because I like to be crazy like that. And you could also write them in different ways, like word form or dot dot form, colon form. Sorry, that's what that's called. Did I do 10 and 30? Let's try 10 to 30. All of those would be perfectly acceptable. Okay, let's do this other one over here, which I'm sure you guys already did, but I'll solve it real fast. 4 and 11. So I highlight the 4s. That's not a highlighter. Let's try again. Highlight the 4s. Oh no, I don't have any 11s on here. Oh, blast. That's unfortunate. Okay, well, I could probably... That was weird. I could probably imagine what my 11s would look like, or I can write them in real fast. 11, 22, 33, 44, 55. Okay, those are a little sloppy, but you get the idea. And then I could come down. That would be 11, 8 and 22, 12 and 33. Oh, guys, I'm a hot mess tonight. Okay, we're going to do 8 to 22 and 12 to 33. Because I just multiplied both of those numbers by 3 up there to get 12 to 33. Okay, so here's your level 3 try-it problem, and I just realized my multiplication table was a little too small, so I just added 14 at the bottom to it. Now, if you ever get to a problem and there's no multiplication table or it's too small, you can always create your own, of course, or you can look for a different strategy or use a different strategy. So in Keith's baseball game this year, the ratio of times he has gotten on base to the times he has been at bat is 4 to 14. So what that means is he gets on base 4 times for every 14 times he bats. So he's not doing too good. Write two ratios that are equivalent to 4 to 14. Go ahead and try this one on your own. Okay, so I could highlight my 4 row, and I could highlight my 14 row, and then hopefully these will match up. So we started with 4 to 14, and then it would be 8 to 28, it could be 1. Oh my goodness, every time. 8 to 28, or 12 to 42, could be another one. Or if you chose to do a different one, 20 to 70, that would be totally fine too. So those are just some options for how you would solve this problem. Okay, 2 more problems for today. I want you to, this one you're just going to write into the Chromebook. Use the multiplication table to write a new problem involving equivalent ratios. So think of the problem we just did with like how many times someone stands up to bat and how many times they get on bases. So write a problem like that and then give me the solution for it. So you can just go ahead and do that in the Chromebook now. So that was definitely a level 4 problem. This last one is also a level 4, 3/4 problem. So what you need to do, it's a think smarter question. Those ones definitely push our brains a little bit. Excuse me. Determine whether each ratio is equivalent to 1/3, 5/10, or 3/5. Write the ratio in the correct box. So we need to look at 2/4. Is 2/4 equivalent to 1/3, to 5/10, or 3/5? So I'm going to start with 1/3. And I'm actually going to, oh, just kidding. This is a try it problem. I guess I should let you guys try it first. So we'll pause now. Okay, so I'm going to go ahead and solve. I was just really excited to solve this one. And actually my iPad's dying, which is probably the more pressing reason. So I'm going to start with 1/3. I'm going to come across 1 and 3. And then I'm going to look down here. And I'm looking to see if these match up in any of these. Do I have a 2, 6? And then I look over here at these. Nope, no 2, 6. How about a 3, 9? Oh, there is a 3, 9. So I'm going to put 3 9 in 1/3 and cross it out. And then I'm going to keep on going. 4 12ths, nope. 5 15ths, nope. 6 18ths, nope. 7 21st. Oh, look, there's that one right there. Maybe there's a different way to do this, but this is the way I'm doing it today. 8 24ths, nope. 8 16ths, and 9 27ths. So that's all that I found on my board so far. So let's try the next one. And let's try 5/10. So 5, oops. 5, and then, oh man, I don't have any tenths here. That's inconvenient. 5/10. Hold on. Okay, so I decided how I was going to solve this. Since I don't have tenths, I'm going to think a little bit smarter. I'm going to skip 5/10 for now, and I'm going to go to 3/5, and then I'll check the last ones, but they should all be 5/10. So 3/5, if I check my chart, should give me 6/10, which is on here. Make sure I lined up right. Whoa. And 9/15, not on there. 12/20, not on there. 15/25, nope. 18/30, oh, that's right there. 21/35, 24/40, and 27/45. Good. Okay, so that leaves me with 1, 2, 3, 4. And this is what I did, guys. Are you ready for this? What I looked at is I said 5/10 is actually equivalent to 1/2. Because if you notice, 5/10 can be simplified to 1/2. And so I'm looking for any ratios or fractions that are doubles. So see how 8 is a double of 16 over here? So that means that is an equivalent. And 10 is not a double of 30, so that wouldn't work. And then 2 is a double of 4, so that one would work. So where would 10/30ths go? Thinking. Oh, 10/30ths, if I simplify 10/30ths by 10, divide by 10 on each side, that leaves me with 1/3. So it would be equivalent to 1/3. So this one would go over here. 10/30ths. All right. I need to take a nap because I'm tired. But that's all of our video for today, boys and girls. Hopefully that helped you learn a little bit more about equivalent ratios. And I hope you have a great day of learning.